So today I'm going to talk about 3D printers, the second industrial revolution, question mark. I am not a 3D printing expert, nor do I pretend to be. So I'm going to touch on the subject from a designer slash consumer point of view. 3D printers that used to cost 20,000 US dollars not too long ago, you can buy now for below 2,000 US dollars. So obviously that is creating an interest from the market in terms of self-production, and they can squirt anything from chemical reactants to silicone sealant to even food. As long as it's liquid, they can make something out of it. The professional printers, they only differ from the smaller versions in the resolution that they can print, the files that they can manage, how complex the files are, and the size they can print in. The basic technology between the two is exactly the same. So it's a resolution, size, and file complexity difference. And then in 3D printing, there is high resolution printing and low resolution printing. Simply put, in high resolution, the layers they print on top of each other are very thin, even thinner than a piece of paper. So the object that you create, you can actually see the different layers, and they form a very solid object. In low resolution printing, the layers are much thicker, and you see the lines in between the different layers. Obviously, high-end printers, or the more expensive ones, tend to be also high resolution printers. We all know about people making things in their garage that have changed the world, right? If you do not know who these two guys are, and you do not know whose garage that is, maybe you're at the wrong event. You should not be here. For those who still don't get it, I mean, I feel like eating an apple in this garage while I'm using an HP computer, right? Still no? For those who still don't get it, Apple, HP. So what I'm trying to say here is that the maker movement could actually be called a subculture of this hobbyist movement that has been around for a very long time. They use electronics, robotics, 3D printing, even woodwork, metalwork, and even arts and crafts in order to make things. So this is exactly the same as what hobbyists have been doing for many years or even centuries. The big difference with the maker movement is that they use the internet, social media, and other web technologies in order to hyper-share their findings or their innovations. They basically come together as a group of friends, and except from the hobbyist in the garage that was doing everything by himself, they start sharing whatever they're making, and they start improving on each other's inventions. They do it in bigger groups when they go to hack spaces. They call it hack spaces. 20, 30 people come together, and they all have different ideas, and they're all tinkering with new technologies and new innovations, and they show it to each other, and from that interaction, they improve on each other's work. Multiply that with a few thousand people, and you get maker fairs. So maker fairs are basically places, again, where thousands of people show the innovations that they are producing, and everybody helps them improving on that. Even universities are getting in on the act, and they are actually promoting that students from different disciplines come together and try to make something, try to produce something. Or even universities between each other start sharing information in order to make things. So that's the big difference between the hobbyists of the past. These were two lonely guys in a garage, and they tinkered around and made a computer. These guys, maybe they're still two lonely guys, still in a garage, still tinkering, but then they share it with thousands and thousands of people and ask their opinion, and through that process work on improvement. You could separate the maker movement in two different categories. On one side, you have the hobbyist, the guy that just does things because it's fun, and because he can, and because he has some extra time, or he's 50 years old and close to retirement, and needs to do something with his time. And then you have the semi-professional maker. They intend to invent something that will make life better or an improvement, and they intend to produce whatever they make in a startup company with friends. So that's kind of the two categories that you can see in the maker movement. One of their big mantras is that in order to make a thing, you first have to visualize it. and their prototyping and 3D printing can be a very good tool. So you make it on your computer, then you share it with the community gives feedback, you improve, you prototype it, you share it with the community gives feedback, you improve, you prototype. So that is a vicious, not a vicious, but that is a continuous circle, and they do that until their product is perfect. And of course, you can see already the prototyping aspect of that maker movement is very big. And their 3D printing can be a very valuable tool. Sadly enough, design consultancies, we also make things. We can't share anything on the internet and with the world. Our clients would go legally ballistic on us. If we start sharing our innovations before they're ready, they would actually sue the hell out of my company. But it's a good way of innovating. It's a very good way of doing things and crowdsourcing in order to make your products better. So in that you build it, you share it, you prototype it, you rebuild it, you share it, you prototyping environment, 3D printers can be super cool. And as you see here, they have a lot of choice at the moment. So which one is the best 3D printer? I'm not gonna get into that. But it highly depends on what you expect from your 3D printer versus cost. So things you need to look at are, what is it gonna cost me to print something? What is the printing resolution? What is the printing size? What printing speed am I going at? Because what people do not understand, it takes time to print an object. We have all this image that, I push a button and 10 minutes later I got a spoon that I can use. Sadly enough, it's not there yet. Materials used, the maintenance, and then also how does it communicate with my computer. It's obvious from what I just said in these few slides, for the maker movement or the hobbyist, 3D printing is a super cool tool. But also the rest of us, we're all gonna have a 3D printer in our house. And that printer is gonna transform our home, and it's gonna be very easy for us, and we like convenience. And what we're gonna be able to do is print out toys and tools and equipment in any color or any size at a push of a button. So basically what's going to happen is everybody's going to become a designer. Everybody's going to become a designer. I just lost my job, Not good. Well, not really. Don't run to a store just yet to buy your 3D printer. There is a problem with this idea, is that there is a learning curve associated with 3D printing. You first have to buy the printer. Most of the time you have to assemble it yourself. Then you have to learn how to do 3D software, how to use that. Then you have to download files that take a lot of time. Then you have to do the actual printing, which can take hours or even days to complete. And the average consumer simply doesn't have the ambition nor the time to do that. Our time has already been cut in so many pieces that we don't have time to go through this process. And us humans, we are creatures of habit. For now, it's still much simpler to go and run to a store and buy a spoon than having to 3D print the spoon yourself. So, and as you see from this slide here, it's not as easy as it looks. There is a learning curve, and the more complex the product is that you try to 3D print, there is a trial and error. It's not, okay, I just push a button and it's all gonna work fine. You have to learn how to operate the machine. And the general consumer simply does not have that time. So every parent, every person is not gonna become a designer just yet. I just got my job back. Still in business. There is other hurdles more technical hurdles with 3D printing that need to be overcome. First of all, there are studies shown that if you would be 3D printing in your living room, it's the same as somebody smoking a cigarette non-stop as long as you were printing. So understanding that it takes several hours to print an object, that would mean that somebody's puffing away in your living room for several hours. Many people are not going to be happy with that. Then there is problems with intellectual property. So it is going to change somewhat the business world over time. But then there is digital piracy. How are we going to handle that? And 3D printing could very well do to the business market what the internet did for music and the movie industry. How do you deal with patents, how do you deal with trademarks, and how do you deal with digital piracy. More importantly, there is an issue with responsibility on 3D printers. Imagine if I start printing 3D equipment on my 3D printer, like safety helmets, or a wheel on a bicycle, or toys for my children. What happens when it goes wrong? Imagine I break my neck driving or riding a bicycle with a 3D printed wheel. Who is responsible? The owner of the printer? The guy who sold the printer, the manufacturer? Or me, who was dumb enough to actually make a wheel on a 3D printer before testing it? Then if you get to household goods, you can start printing 3D bowls, and you can put your food in those bowls. But if those are made in ABS, this is not toxin-free. What's going to happen when you put a 3D printed bowl in your microwave with your food in there? What's going to happen if you put food in a refrigerator over time in a 3D printed bowl? And there is the problem of hygiene, because they're actually promoting that you can 3D print food. And then there is a question of hygiene, on cleanliness and all that. I'm going to talk about food printing a little bit later, but so there's still some hurdles to overcome. Maybe there is a need for an FDA-approved 3D printing machine, but we're not there yet. So, you know, these shortcomings, I'm sure over time governments will get into legislation and we will sort the materials. But if you look at the immediate near future, mass market appeal for 3D printers from a consumer point of view, I only see an area if they solve one single pain point very well, very easy, and very cost effectively. And they're not doing that. So most 3D printers at the moment are general purpose. And you know, as I explained before, we just don't have the time to do general purpose things. These are two examples of things that are taking the right direction. So this is Mink. It's a makeup printer. Basically what it does, you connect it to your computer. You can take any color from any picture on your computer, and this machine will print makeup for you. It solves one pain point. And if you're a 16 to 21-year-old girl, and you have to spend a lot of money on first-year brands making makeup, this could be a super cool tool. So if they can make it cost-effectively enough, it solves one problem for one target group, then 3D printing could have mass market appeal. Another one, this is a 3D printing pen. It does one thing. So instead of being able to sketch in 2D, the moment you lift up the pen, you can start making 3D objects. Again, it does one thing, one market appeal. There could be a market for that. On the other side, there is industry. In industry, 3D printing is already being used in many, or is in the process of being used in many different fields. And I'm using some examples here of industries that are already benefiting today of 3D printing. So if you're a startup company and you have a 3D printer, you can make proof of concept or even working prototypes at a fraction of the cost of even a few years ago. That's interesting. In the medical world, not only are they printing out prostheses and medical tools, they're actually tinkering with printing skin and organs. And they're actually getting successful with it. So for those who like to drink a lot, maybe in a few years you can get a 3D printed liver or something like that. I don't know. In the aviation industry, 3D printing has been used quite a long time already, because it allows them to make parts that are much lighter and keep the strength of more traditional metal components. In prototyping and in my industry, in the design industry, 3D printing is used to make prototypes. And what we used to do, allow me to elaborate, is we either used to make hand models, or we're still doing that today, or we go to a CNC milling shop where we make our prototypes. Now, the advantage for 3D printing over handmade models is that to make such models takes 1 or 2 days valuable designer time away from the designer. And if you do that with 3D data, if you need to tweak your models, it's much more accurate because you're using actual mathematical data in order to make your tweaks. If you do things by hand, it's still the eye, yeah? You know, shave off a little bit here, add a little bit there. I'm not saying that model making will go away. It's part of what we do in our business. But later iterations, a 3D printer takes over a lot of the footwork for us in order to do so. With CNC prototyping, 3D printing has one advantage above all: it's much faster. It takes about 5 to 7 days to CNC a model for us. And if we are in the iterative process, if we can have it overnight, we actually, if you imagine we make 10 different prototypes before we get to mass production or to the next phase, 10 times 5 days, 50 days that we lose just waiting for our models to come back. And only in the last phase we would still use CNC prototyping because it's a little bit more accurate still. There is an environmental advantage that in CNC prototyping you start with a plastic or a metal block and they take away material until you get your product. In CNC printing you only use the material you need. It's an additive product, so an additive process. So actually it's a little bit better for the environment. Back to my previous slide. In education, they're already starting to use that. If you have to build complex structures or molecule models or even other education tools, a 3D printer can do that overnight, and the next morning you have your materials ready for the class. In mass production, 3D printing can be very good if it's low volume, high complexity parts. So there is things that 3D printers can do that you simply cannot do with other mass production processes. And in that case, 3D printing can help a lot. In the food industry, believe it or not, they're going to actually be able to mass produce food using 3D printers, especially layered foods. They're already working on that. There are companies in the market that are saying, oh, there's going to be a 3D food printer in every home. And it's going to be as revolutionary as the microwave was in the 1970s. Again, I have to disagree, because the microwave was successful for one sole reason. It saved us a lot of time. Things that used to take half an hour now take 2 minutes. 3D printing food is not going to save us time. First, you have to make the food liquid. Then you have to put it in a machine. Then you have to 3D print it. Then you have to put it in the oven. Then you have to cook it, and then you have to clean your machine. So it's not going to revolutionize the kitchen industry like some say. There may be use for it. I'm not saying that there may not be use for 3D printing in food, but not in the way that some people make us believe. So to give you a few examples of where it has been successful on a product basis, here are some very cool ideas. So for instance, in the medical world, 3D printing is very cool because it can leave very rough structures on prostheses, and it also can do honeycomb structures very well. And when you have a prosthesis and you have a honeycomb structure, the bone grows straight back into the prosthesis. And that's a natural bond. So no more staples, no more screws. It grows back naturally like it was part of your body. In this case, this is an example of somebody that 75% of his skull replaced by a 3D printed prosthesis. The dental industry, actually 3D printing is going to revolutionize the dental industry. So what is happening more and more, especially in Europe and in the US, is dentists are starting to take data from your mouth by 3D scanning. So no more the clay, no more sitting for 15 minutes like this. I think it's hard, I think it's hard. No more. They just put a scanner in your mouth and they take all the data from there and it's done. So to take the step from 3D scanning to 3D scanning dental implants is just a very small step. And actually, I think it's going to revolutionize the dental industry quite a bit over the next 5 to 10 years. What the tire industry is doing is they can make metal tools with much smaller walls and much sharper edges and much more complex structures than they ever could do before. So tires are bound to be improved a lot the next few years in grip force. In the mass production industry, this is actually a core side of a plastic tool part. Basically, this is how they make a cup. They put another part on top of it, they squirt plastic through here, and then they have to wait until it hardens. And then when it's hard, they can take the tool apart and can take the plastic cup out. So now they are placing, again, metal sintered cooling systems, very complex. This is something you cannot produce with a normal production process. They use laser printers to make these so they can cool the core much quicker, hence they can speed up the production process quite a bit. There is a Dutch design studio that's very successful. They use 3D printers to make customized low-volume household and lifestyle goods. And there is an added value to that. It's because it's low volume, they become collector's items very quick. And they're quite successful because they don't have a supply chain, they don't have to think about logistics, and that gives them quite a good profit margin. This is a website, Shapeways. Shapeways is a website that connects designers on one side and the consumers on the other side. They can do customized prints or customized designs for the consumers, and then the consumer can print that out at home. So in this case, you may go, hey, there is a mass production scenario. I can use this, and these guys can design it, and I can print it out at home. Not just yet, because the maintenance and the setup of a printer, it's really not that easy. However, there may be a case scenario for 3D printing shops all around the city. So if somebody is interested in a new business model, that could work. So I see a solution where, when I was a student, we used to go to a paper copy shop. All my exams, they were copied, on a copy machine there. I see a similar scenario for 3D printing shops all around town, and they'll deal with the maintenance, and they'll deal with the setting up the files and cleaning and the equipment, and you just walk in with a file and they print it out for you. The airline industry. Boeing has printed 20,000 3D parts already, and they're used both in military and civil aviation. And their 787 Dreamliner uses 30 different 3D printed parts. And the main reason for that is they print out parts at much less weight with the same strength. So, for instance, in the Dreamliner, all the tables that you put your food on, right? There's metal bars on each side. They used to be aluminum extruded. They are now all 3D printed, and they're hollow inside. And I was at a presentation a few weeks ago with the company that actually makes these parts for them. And I forgot the exact numbers, but they explained to me that if you save 300 or 400 grams on a part in a Boeing, over the lifetime of that airplane, the airline company saves millions and millions of US dollars in gasoline or in kerosene. So that's also why airlines are very annoyed with your luggage being overweight. When your luggage is overweight, the plane will still take off. It's not that the plane will not take off. It just costs much more to get your heavy luggage on the other side of the world. So that's why they charge you more. Nike is very aggressively pushing 3D printing throughout their entire product line. So last year they made the special 3D printed shoes for the Super Bowl. And they're saying they're going to use 3D printing in almost all of their upcoming consumer, or at least shoes and some of their consumer goods. They don't want to give any details. I'm sure Adidas would like to know what they're going to do with 3D printers, but they're not telling anybody. But you see already in their high-end gear, in their semi-professional and professional equipment, they are implementing this 3D printing technology today. You may not know that, but every time the US military deploys on the other side of the world, they spend 2 to 3 billion, not million, 2 to 3 billion US dollar getting equipment and replacement parts to the other side or to the operating theater. Whenever they leave the operating theater, and most people don't know that, they lose another 2 to 3 billion US dollar just leaving stuff there. You know why? It's cheaper to leave the parts there, to leave things there, than to ship it back to the US. So in that case scenario, 3D printing could be a very cool tool. So in the near future, I'm sure that some generals are looking into it to get 3D printers on the theater, and if you have replacement parts, you print them as you need them, and you don't have to ship extra parts all the way over the world. NASA is already using 3D printed parts in a lot of the satellites and a lot of, not rockets, but the tools that they send into space, for the same reason than airlines, the weight. If you think airline companies know a lot about weight, these are the best dietitians in the world. The weight is everything for these guys. So they are now planning to send 3D printers to the International Space Station to 3D print parts and tools right there. Why? It would save them a lot of cost in having to fly them there. So that is an interesting development for the near future. So, what have we learned today? Well, some people will, we're not going to print out our toys and our instruments and our electronics just yet. We're not going to do it. Why? It's too time consuming, and we don't have that time, we don't have the ambition to do so. Unless 3D printing is solving a pain point, one single thing, very well, in a very good and effective way, then it could have mass market appeal. But a general purpose 3D printer, I don't see it happening, in the near future. On the other hand, if you are a hobbyist or you're deeply entrenched in the maker culture or the maker movement, after this presentation, run to your first store and go buy a 3D printer. You will love it. This is exactly what you would like to have in order to make your equipment. In industry, any industry, the chances are that 3D printing is somewhere going to be used in your pipeline. So if you are not looking at it, please start investigating it, because others are going to do it, and you're going to run behind and you're going to lose market share. Is 3D printing going to revolutionize the world? You bet it will, but not in the Futurama, I'm going to print things at home and I'm going to make my own spoon kind of way.